For your specific heat and heat problems, we're going to use one equation. The equation that we use is Q is equal to mc delta T. So I'm going to start off first with explaining what each of the letters actually mean, what we plug in and what we use for units for each one, and then we're going to start and we're going to do a couple example problems as well from your note packet. So this Q that's right here, this is heat. The heat can be absorbed or lost, so you can have a positive heat number or you can have a negative heat number. For your heat, we're going to measure that in joules. M is your mass. Your mass we're going to measure in grams. If you don't have grams, you're going to convert, so you do. This C right here is called your specific heat. Your specific heat is a constant value, hence the C. And with that specific heat, you're always going to plug in the same number no matter what. When you plug in that same number no matter what, it's going to tell you how much energy that it takes to raise 1 gram of that substance that you're dealing with in the question 1 degree Celsius. And then delta T goes together. This little triangle right here is a delta. That delta just means change in. So this is your change in temperature. To find a change in temperature, you're going to take your final temperature minus your initial temperature, and you're going to subtract the two. So your ending temperature minus your starting temperature, and plug in that value here. The unit that you're going to use for that is degrees Celsius. So because of all of that, your specific heat, you end up with a quite a bit of a unit. It's joules per gram degree Celsius, and that's just to get everything else to cancel out. So we have all of the units that are necessary for the equation. The only other thing that we need to know is the specific heat of water is not usually given in problems. That's a number that you're expected to know. The specific heat of water is 4.184 joules per gram degree Celsius. That's a number you'll have to know for your test, and it's only for water. Basically what happens with your specific heat is the higher the number, the more energy that it takes to raise the temperature of the substance. The lower the number, you're going to take less energy to raise that substance 1 degree Celsius. So with your metals, you're going to see like 0.125 or 0.37 and things like that. You're going to have very small numbers because it doesn't take a whole lot of energy to heat it up. But then your specific heat of water is actually quite large. I know it's only 4, but it's still a pretty big number. So what we're going to do with this MCAT equation is what we call it, is we're going to use it in some math problems. Q is equal to mc delta T. In your notes, that's where I got these from, this is the very last part of your notes. It says the temperature of a 95.4 gram piece of copper, so this is a mass, increases from 25 to 48 degrees Celsius. So that's going to help us get our change in temperature. When the copper absorbs 849 joules of heat, what is the specific heat of copper? So we need a change in temperature. So we're going to take 48 minus 25. 1 decimal place, 1 decimal place. We get 23.0 degrees Celsius for your delta T. Final minus initial. And then your Q, your heat, is measured in joules, so that's 849. So now we can just plug everything in. 849 is equal to your mass, 95.4, times your C, we don't know, times your delta T, change in temperature, 48 minus 25 was 23. So now we solve for C. To get C all by itself, we're going to divide this side by 95.4 times 23. So 849 divided by 95.4 times 23. I have 3 sig figs that I need for my answer. So we get 0.387. We're solving for specific heat, so it's joules per gram degree Celsius. And that is your answer. That makes sense because we have copper. Copper doesn't take a whole lot of energy to raise the temperature, so that's a pretty small answer. So that would go right. On the next problem, it says that we have 43 grams of water. At 28 degrees Celsius, it absorbs 1,605 joules of energy. what is the final temperature of the water? So on this problem, they're giving me my mass. They're giving me the fact that I have water. So my C is 4.184. This one says that this is my initial temperature. So I'm going to put TI for initial temperature. And then I have Q. I don't know final temperature. So what I'm going to do first is I'm going to plug in everything. 1605 is equal to my mass times my C, 4.184, times delta T, that's final minus initial. So you can either solve for delta T here, or you can plug in your final minus initial, however you want to do that. So we need to get delta T all by itself. We're going to divide this side by 43, divide this side by 43, divide this side by 4.184, 4.184. So 1605 divided by 43, times 4.184, and we get 8.92 is equal to delta T. So that's my whole change in temperature. What I need is my final temperature. So now I'm going to sneak over probably just to my paper. We know that your delta T is equal to final minus initial. We know our initial temperature was 28. We don't know our final temperature. Our delta T is 8.92. So what we want to do here is we need to get final all by itself. So we're going to add 28 to this side, add 28 to this side, $36.92. This is a whole number, so that means that this answer has to be a whole number. So we get 37 degrees Celsius for my final temperature. So we had to kind of work backwards, get the delta T first, get the delta T first, and then plug it into your final minus initial to get just that value right there. You also could have set it up all at the same time if your math skills are worthy of it. So delta T is equal to final minus initial. So you could have plugged in 1605 is equal to 43.0 times 4.184 times your final minus 28. You could have done that. It's the same exact thing that I did. I just did one extra step instead of writing it all into the equation. So either way, you get the same answer for your specific heat problem.